Welcome back. This is series number 9. Series number 9. In the dynamics, I was trying to tell you, if you recall, even in my previous lecture, uh, I introduced the concept of centrifugal force. The reaction of centrifugal force is centrifugal reaction, and we introduced another inertial force, fictitious force, that is called by special name centrifugal force. Centrifugal force and minus MJS that you have taken, we have so far seen two inertial forces. One, minus mass of the body into acceleration of the system, and minus mv v square by r cap. This is called centrifugal force. There is no name given to this, and whenever you use this, you will get only relative acceleration. This is what is said. Now, what is the fundamental topic that we are discussing? Discussing basically the normal force. Now, I'll tell you, I take a case like this, where the body is going on top of a convex surface with certain velocity v. So the normal force here is this, mg is like this. What is the centripetal force here? Towards the center mg, away from the center is this, or n is equal to. Now look, whenever there is a speed breaker or something, and a vehicle goes at the top of it, we are looking at this. What could be the normal force? We're getting mg minus mv square by r. That means there is a chance that this might become 0 if n is 0. Means what? Loses contact. The body and the surface lose contact. So what is that value? From this m gets cancelled, v square is here. What do you mean by this? Is the critical value. So v must be less than or equal to the critical value for the body not to lose contact. Be careful about this. For the body not to lose contact. This is a ticklish problem, and if I now take inside, suppose a body is going with V and it is not falling off. This is down. Now be careful. This is the curvature. It is now going. You get the point here? Surface. This is how the body is going. It is pressing. So it will press it down. So n here, obviously mg here. So what is the centripetal force here? That is the centripetal force. And what is n plus mg equal to? mv square by r. So what is n? This we will call it as an outside. This is an inside. There is a hollow, say maybe A cylinder or a sphere where you see in circles and all that, the vehicles keep on moving in any direction of their choice, and we enjoy it, how it is possible for him to move up and down, etc., etc. Now this is how I call it as inside, so that you can avoid any complication there. That means there is a negative sign. Here also it can be 0. And Ni you want it to be positive, so that the body does not lose contact with the surface. Okay? And here you could see same greater than 0. So V must be less than this. But here what are you getting? This must be greater than 0. Or Vc is equal to root gr, but your V must be greater than or equal to root gr. It's a very, very important consequence. Follow these two carefully. This is the minimum value that otherwise body would fall. This is the maximum value, otherwise the body would lose contact. You have to be very careful with this. I've taken two possibilities likewise. Right? Now, when I go to the other one, suppose if I go with the concave nature. Suppose it's going with V. N is like this. Mg. What is the centrifugal force? N minus mg. All towards the center. And this is equated to. So what is N here? N can never ever be 0 here. And if you have a speed breaker which is concave in nature, bodies will never lose contact no matter with what velocity they come. Of course, if they come with more velocity, purpose of speed breaker is completely lost. Now, suppose I take, this is the center, the body going like that with V, let this angle be theta, as usual mg, that is N. What is N here? Normal force by the surface on the body. Okay? Now, if I take the component here, mg, this is also theta. What is centrifugal force here? N minus mg cos theta, and that is equated to, with this V I am taking everywhere is not the same. In each case, the V is a general velocity I am considering, magnitude of course. So N is equal to mg cos theta plus mg square by r. So you can take it at any point. Let theta be 90 also you can take it. Example. Suppose it's going up. What is N? Mg is like this. It's going up. So it is going. There is no other force acting in the horizontal. What is centrifugal force here? Only N. And that is equated to mv square by r. Mind you, this V is different, this V is different, V is different everywhere. Okay? So you got it. Each case you have to work out separately. I am taking inside, I have shown you here, I have shown you here, I have shown you here, and I have shown you here. Now let us see if I have to go at an something like this. normal force, that is V, mg, if this is theta, this is theta, this is mg cos theta. What is the centripetal force here? Mg, this is the line of radius towards the center is mg cos theta, away from is n, and this is written as mv square by r. Rn is equal to top general point theta 0. So now possible that it could become 0. If it becomes 0, then what are you getting? M gets cancelled. Is under root gr cos theta. I want you to understand it is going up like this. The loop, entire loop the body is going. Try to give you various possibilities here. Now let us try to look at suppose it is like this. This is semi-vertex angle. This is a cone. I put a body here. Now this is N. This is mg. You know, this angle is also theta, alternate angle, right? So mg is like this. This. This is theta. So this is mg cos theta. This is mg sin theta. What is centripetal force here? N. Oh, this is mg. This one. This is N. This is mg. Now, if this is theta, this is theta. Now the circle of motion is like this here. Okay? What is this that you would write there? N cos theta. That is your, if it is moving with V, or you may write it as mr omega square. So what is N means you have to give mr omega square by cos theta. But this R is this. And here the cone's radius is capital R. Right? Now you can very clearly see if I give this as H, this as L. Now cos theta is H by L. You can write in that fashion. Possible. Or if you know what is this point, and if this is say H dash, you can write it in terms of capital R also. Anything you are free to do. You can write that it will be like this. This is a normal force when a cone is rotating and you keep a body there. Okay? Fine. Now if I take a cylinder, suppose it is rotating with omega, I am placing it on the sidewall. Obviously this is N, this is mg, and the centripetal force is N. Therefore, here there is no difference in this. So N it becomes mr omega square. That's it. So I have tried to show you on horizontal surfaces, vertical surfaces and curvilinear surfaces. Okay. Now, in the same way, supposing I subject this whole elevator is accelerating up, I am placing a body down here, obviously mg. What is a normal force here? Now, without doing anything, you can say m minus mg is accelerating up is equal to ma. Is one way of doing it. So that n becomes m into a or g plus a. Now, I can also take if it is accelerating up in the frame of reference of that elevator, pseudo force acts like this, and with respect to the elevator, it is stationary. Therefore, n is equal to m into g plus a. Either way I can write. Now, one very important thing I want to tell you. If elevator moving down, that is not the criteria alone. I'll give you all possibilities here. Now look, follow me a little carefully. Plus a up, elevator accelerating up. What is n? mg into 1 plus a by g. Minus a down. Both are same. It is retarding downwards or accelerating up. Impact is same. In a similar way, plus a down or minus a up, what will happen here? One minus a by g. Accelerating down or retarding up, then becomes mg into 1 minus a by g. Now, uniform velocity. So, up or down. N, no change. You will get only mg. N becomes mg only. So, whenever they say accelerating up or down, always look at, is it accelerating up or retarding up? Accelerating down or retarding down? Or stationary? Or whether it is moving with the uniform velocity. When it is moving with the uniform velocity, whether it moves up or down, it makes no difference and will not change. This is how you have to understand in non-inertial frames. Okay? This is how your... Now a peculiar case arises. Look at the second one. What do you get? This is the elevator. This is where the body is. Okay? Now, suppose if I say A is equal to G. It's accelerating down, A is equal to G. What will happen? N becomes 0. That means what? Contact is lost between the two bodies. And after some time, that is both are accelerating down with same value. So they move, but there is no pressing in between that, in which case n is equal to 0. Now they may ask, in time t, what is the displacement of the body? It is as though the body is dropped freely from a state of rest, say u0. So, S is equal to half g t square. That's it. That's it. The elevator also moves down by the same amount. body also moves down by the same amount. So it's straightforward, simple, no complications. But now look at this. Plus A down, but A is greater than Z. That means what? After some time, body is there. After time t, what has happened is there is no contact between these two. Elevator is accelerating down, what will happen to the body? Body also falls down. Body accelerates down. With what value? It is a freely falling body, so body falls with the G with respect to the ground. With respect to the ground. So in time t, how much it has travelled? Half gt square only. In the same time, how far has the elevator come down? Half at square. Maybe a is 15. So in 15 meter per second square, initial velocity 0, this is how it has come up. Obviously this is more, this is less. Remember, both are falling. But body moves up with respect to elevator. In reality, when you watch it from outside, body keeps falling. Under gravity it falls. So there is no issue with that. But if you are inside that and you are holding on to, in fact if you stand there, you will also, I will give you here, you think that you can watch it. Now your position also will be like this. Your position also will be like that, my dear friend. Now, but if you have a fixed point here that you can change yourself to the surface of the elevator inside, then you can see this body going up. So with respect to you, how much the body moves up, h is equal to half into a. Very simple. Half at square minus half gt square. That's it. This is how it goes. And this is goes and then gets stuck to the ceiling. Likewise it is. But don't say n is negative, n will be 0 or positive. N negative has no meaning. Okay? Is this clear to you now? When you take elevators. Right. Right. Now we go on to another very important. What we saw, I'm still looking at normal force. The normal force on inclined surface. Let me take it as beta. The whole thing is fixed incline. Putting the body of mass m. This is smooth. If I release it, it will come down. You know, if I am plotting the FBD there, n, this is mg, this will be mg sin theta, this will be mg cos theta, and the body will move down, but n is equal to mg cos theta. N is equal to mg cos theta. Okay? This is a fixed inclined plane. Now, I put this inclined plane, say, center. I put N, and this is mg, this is mg cos theta, and this is mg sin theta. I am taking plus A up or minus A down. In this case, I am directly using pseudo force concept in the FVD. Going up means a down will be like this. Therefore, this. So what is your N here? M cos theta into R, we can write it as mg cos theta into, no issues at all. Then, if somebody asks what time it takes, if this length is L, L is equal to half A plus G T square sin theta, because the component there is sin theta. That is from kinematics. We did it before, and the same thing. I got it. Now, if it is accelerating down, so don't try to answer whenever they say elevator is moving up or moving down. What should they specify? They must necessarily specify whether it is accelerating up or accelerating down. Then only we can answer. Now, if I take plus A down, what will be your N? Directly I can write minus A by G. Got the point, I suppose. That is how we have to write it. Okay? Now, this is as far as the elevator is concerned. No change if it is moving up or down with the velocity. Now, look. Now, this is a smooth surface. Here is the body. Maybe this also is having certain mass. Now I am getting into the complications of how to get the normal force. You have to be very careful in answering these things. You can no longer write N is equal to mg cos. I think I have written theta there. I took beta. Be careful. You use beta only instead of theta. In my little while ago, we tried to put it. Now, supposing, look at that. As this moves, this starts moving backwards. It presses it. So, because there is nothing to oppose, this body or inclined surface will move backwards. As M moves down the incline moves backwards. Let this backward acceleration be V. It's moving with V. Now, I'll first of all show you how does the whole scene look like. I'll put the diagram here. You have to draw these things perfectly so that they won't be. This is how body started. After some time, let us say, this inclined surface has, I think you can easily visualize the diagram. This is beta. This body must have come somewhere there. Body is not coming down. Body is not moving along the incline. Body is having a very, very typical movement. Very, very typical. In fact, don't get carried away with the diagram. It would be like this somewhere. Now this is a very crucial thing. The movement or displacement, the velocity and the acceleration of these two are interconnected. They are not independent of each other. Whether the body moves on its own or the inclined surface moves on its own. Therefore, what is that interrelation between the two? Now, if I am able to get it, I will call that a constraint equation, as we have done in the case of pulleys or the strings, ropes, chains, etc. What did we do? The condition there was the total length of the rope is constant. It was an inextensible rope. Here, what is the constraint? This is a wedge. Therefore, this is called wedge constraints. In wedge constraints, what you have to see, choose your y, x and y, because this is in the plane, x and y axis. Say, for example, I will choose this as x axis, this as y axis. Okay? Parallel to the incline as x axis, perpendicular to that is y axis. How far this has moved? Let me call these 2 points. Yes. This is where it has come. So, as far as x is concerned, this is x. What is y? This is y. Or this is y. Both are same, isn't it? So, perpendicular to the incline it has moved by y. Parallel to the incline it has moved by x. This is how it has moved. Okay? Right. Now this is beta. Can you tell me what is beta? So, your s and y are interconnected. Be careful. S and y are interconnected, but not x. Why? From the diagram, whether I take x here, 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 your y is the same. If s is more, y will be more. If s is less, y is less. Is such a relation you can't get for x when x is parallel to the incline. You get the point? So what is the relation? Now look at, try to construct a right angle triangle. That's it. And now this is sin beta is equal to y by s. Or y is equal to s sin beta. Vy is equal to vs sin beta. Ay is equal to b sin beta. This is the constraint relation. I hope you are able to understand this. You got this? In the case of wedges, constraints can be given only when x and y are fixed. Otherwise, not possible. Now what do I do here? Why did I get it there? When I want to apply my Newton's second law, I know that this is n, this is n g, of course, this is angle beta, and now this is mg cos theta, this is mg sin theta, and this accelerating down the incline along x-axis with ax, it has a movement towards y also. So let its acceleration be ay. Remember, there are two bodies here. One is inclined, other is tiny body. First I am doing for tiny body. How do you write your equations here? Along this there is no other force. So mg sin theta is equal to mx So m gets cancelled. So your ax is nothing but g sin theta, straightforward. What about this? Sorry, I'm putting theta here, be careful. It is beta. I'm getting okay, everywhere beta. So mg cos beta minus n is equal to ma by. Okay, so mg cos beta minus n minus ma by. Now this also we will use it. B sin beta. Okay. I have got the second equation from this. What about the FBD of this thing? That is also another body. You have set it as okay. Now this is here. Be careful. The previous case, what did I do? This is N by the incline on the body. Reaction is by the body on the incline. Action, reaction are opposite to each other. So you have it. Okay? This is capital Mg. And now if I resolve this, now this is beta. So this angle will be beta. So this is n cos beta. You verify whether it is beta or not. It is very simple for you to get it. How do I write the equation now? Suppose if I am writing like this, there is another normal force here. Wherever there is contact, there is a contact between the incline and the surface, so n dash has come. So n dash down is n cos beta mg. That's it. So I write it here. N cos beta plus mg. And in this horizontal, n sin beta is equal to m into b. I'm writing it here. N sin beta. There is no other force acting in the horizontal as far as incline is concerned. Now I have written all the equations. So now we look at n sin beta is mb. And ay is nothing but b sin beta mb sin beta. Eliminate b so that you will get n. So I try to divide these two. What am I getting? Mg cos beta minus n is n sin beta. I brought it onto this side. Nb sin beta by nb, db gets cancelled. This m comes here. Mng cos beta. This is a capital Mn. There is m. Brought it now. Mn plus n m sin beta into sin beta or n into therefore n is equal to mng cos theta by n plus very important relation. You can look at how complicated this expression is. In the same inclined surface, When it is stationary, one value, elevated up another value with elevator. When it's going down with elevator with acceleration, another value. I take a body just released on its own and this is moving backwards. You are getting capital N is equal to this. Once you get N, you can get B also. What is B? Is all this you can write. G cos theta gets cancelled. So mg cos theta, that is B. Once you get B, you get Ay also. So Ax is known, Ay is known, B is known, N is known. And in the process, I'm trying to work out even other things also. So now you got N is equal to mg cos theta by m capital N plus m sin square theta. Okay. Now I have made use of the constraints here to get this answer. Now I'll show you how to make use of same problem, second method. I want to use pseudo force technique. This is the body N. If this is accelerating with V, N perpendicular to this surface. This is mg cos theta now B, so pseudo force is small m into V. Mass of the body into acceleration of the system in the opposite direction. So you got it mg because everything is here. But this mb sorry, again I am putting this theta. So what are you getting here? MB, because this is beta. This is beta. MB cos beta, MB sin beta. Now remember, when I draw FBD, this is a non-inertial frame. I want to use pseudo force. I have used pseudo force. Now when I write it, I got these two components. Pseudo force means what do you get? You get only relative acceleration. Acceleration of this body with respect to incline. When you say with respect to incline, inclined is stationary. If inclined is stationary, this will move parallel to the incline only. Therefore, your relative acceleration is parallel to the incline only. Perpendicular to the incline, no acceleration, that is 0. Therefore, there is a balance of forces in the direction normal to the inclined surface. What is that? N plus mv sin beta is equal to mg cos beta. And in this direction, mg sin beta plus mg cos beta is equal to NAR. I hope you got it. Right? Now you draw FBD for incline. That will not differ. This is N. This is N sin beta. This is N cos beta. So N sin beta as before is equal to small m, capital M into B. And in this direction we have already put it there. The same thing. I need not repeat that. So N dash is equal to mg plus N cos beta. So I have written down all the equations. Now you have to solve. What do you get? This AR n, b, three variables, three equations. If you consider these four variables, four equations, you will get it. So, for n, what do you write? mb by, or what do we do? Shall we take these two and eliminate b? What do we get? We will see. B is equal to n sin beta by capital N. N sin beta by capital M is equal to mg cos beta. So what do you get? N into m plus m sin square beta. You see? Got the result very easily. mg cos beta by m plus m sin square beta. This is n. You verify your n. You got it. We were using constraints there. We are using pseudo force here. Answer is bound to be the same. And once you get n, b also is same. Only difference is AR. See? Now, what is B? If I substitute here, capital M gets cancelled. You have mg cos beta by. Substitute in this and get the value. Now here, m gets cancelled everywhere. So I am going to get that also additionally for you. G sin beta cos beta mg cos square beta by m plus m sin square beta is AR. So G common is m sin beta plus m sin cube beta plus m capital M sin beta m sin square beta m cos square beta. You got it here? What do you get? MB, B, M is all this? Yeah. You will get another sin beta here. Because when you substitute there is a sin beta we can't ignore. So I'll do this again. N sin beta. So I want to get G sin beta plus cos beta into B. B is all this. Cos square beta sin beta m by m plus m sin square beta. Is it clear to you now? Now you can simplify this. There is G also there in this beta. So mg you get it. So G is equal to m sin beta plus m sin cube beta plus m cos square beta sin beta. Now you better simplify it further. If you see one sin beta is common everywhere, you can see. So G sin beta, you get m plus m sin square plus m cos square. M by this is the value of Yeah. I'm only trying to give you, along with this, we can get this also. So this is a relative acceleration. These two values will not be the same. Okay? The previous case, when I took the constraint I was telling you, you have to fix your xy, then only you will get constraint. So in the previous case, you got ax as g, sine beta, ay as a function, we got it, and in this case, we have got like this. Same problem. Your x is like this, y is like this. Same problem. I'll show you. Initially, this is where the body, after some time, it has gone like this. So this body might have come here. We don't know, something like that. Okay? Now, x is like this, y is like this. I'll put it in such a way so it is easy to conceive the view. Let it be here, 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 it makes no difference. Let this be s as before. This is small x, this is small y. Now you can see S, X, Y, all are interconnected. In the previous case, S and Y only were interconnected. So you will get the constant relation between S and Y. Now you will get between S. Now you see how I identify one right angle triangle. You got it. So tan beta is Y by S plus X. So differentiate, you will get velocity. Further differentiate, you will get acceleration. So Ay is equal to V plus Ax tan beta. Now while writing the equations, you have to write appropriately. Your x is like this, like this, like this. So take the body. This is N. This is mg. Now you have to do it in the horizontal and vertical. What is the direction in this? Acceleration in this direction, ax. So how do you write the equation there? How do you write the equation? N sine beta is mx, and in this direction is going down, therefore mg minus n cos beta is equal to may. Be careful, we have got ax like this, ay like this. So in the ay you have mg opposite n cos beta. Therefore, I have written the second. Third equation remains the same. N sine beta is equal to mb. Okay? Now very simple. You can easily, ay is equal to v plus ax tan beta. Now I told you, whenever you have to solve this, look at the equation with maximum number of variables. In that everything you keep. What is Ax now? N sine beta by small. What is Ay? Ay is all this. So I will write Ay is mg minus n cos beta by m. Ay is equal to b. B is n sine beta by capital M into tan beta plus Ax. Where is Ax? N sine beta by m tan beta. See, Ay is equal to b plus Ax tan beta. I have written. That's it. Now you have to simplify that. I have to bring everything onto one side. G is equal to, this is m common, cos beta by m, this term, plus sin beta tan beta, that is sin square beta by cos beta capital M, plus again sin square beta by cos beta small m. And now you have to find the Mn. Cos beta is LCM. So you get m cos beta I into cos beta. Now this is m sin square beta plus capital M sin square beta. All this multiplied is equal to G. Therefore, n is equal to m G cos beta by m cos square plus m sin square is m plus m sin square beta. Look, again you get the same answer. N I have tried to work out with three possible ways. 1 using constraint, 2 using pseudo force, 3 using again a constraint here. So I got it. I think I'll put a stop to this here. We'll continue.